So I'm going to go over the ideal gas law. This is the last of the gas laws, and this is the one we're going to use the most. The ideal gas law relates volume, temperature, pressure, and number of moles. The moles are represented by the variable N, which we may have used before. I can't really remember, but N is number of moles, and you get PV equals nRT. So P is pressure, V is volume, N is number of moles, of course. R is the ideal gas constant, and that changes depending on what unit you have. So if you're using kilopascals, you're going to want to use this one over here. If you have atmospheres, you're going to want to use this one. Most of the time we're going to use atmospheres, so kind of commit this one to memory. So a lot of times, T is temperature, of course. I can't remember if I said that, but a lot of times we just call this PV nRT because that's kind of what it spells out. So if you hear me say PV nRT, I'm talking about this equation, PV equals nRT. Just like all the other ones, you're only going to have to solve for one variable. Remember, the temperature must be in Kelvin always, and then make sure you've matched up your gas constant with what type of pressure you have. So here is a typical question. A deep underground cavern has 2.24 million liters of methane, a pressure of 1.5 times 10 to the 3rd kilopascals, and a temperature of 315. How many kilograms does the cavern contain? Well, if you have kilopascals, like I said, we typically use atmospheres, but if you have kilopascals, you're going to use this constant over here to the left, 8.31. So the pressure is 1.5 times 10 to the 3rd, so that's P. V is 2.24 times 10 to the 6th liters, okay? And that equals, I'm going to go to the other side of the picture, sorry, equals N, which is what we're going to solve for because it wants kilograms, but you know how to get from moles to grams and from grams to kilograms. R is the gas constant, like I said, 8.31. And then T is the temperature in Kelvin, which is 315. Okay, so that's R, this is T. So we work this out and we solve for N. When you do that, you get 1.28 times 10 to the 6th moles. And then it's 16 grams per mole. And once you get that, you can convert that into kilograms. So you end up with 2.05 times 10 to the 4th kilograms. And that would be your answer. All right, so I'm going to talk about more in a next video, but for the first set of problems, that is all you're going to be doing. So let me know if you have any questions.